Something extraordinary is happening at Georgia Tech. We're transforming approaches to disease and human health through a visionary new facility, the Engineered Biosystems Building.
The Engineered Biosystems Building will be a strategic resource for the biosciences sector, one of the fastest growing industries in the state. EBB will provide outstanding faculty, students, and staff with the resources they require for success. It is an investment in our future. The Engineered Biosystems Building has the potential to take Georgia Tech's science and engineering programs to the next level. It will provide an environment for discoveries, many of which will become innovations that will save and enrich lives for generations to come.
As a public-private partnership between the state of Georgia and the philanthropy of individuals, corporations, and foundations, EBB will provide 200,000 square feet of multidisciplinary research space. The building has been designed to bring together scientists and engineers to increase our understanding of complex diseases and to generate new drugs and new therapies for cancer, arthritis, diabetes, Alzheimer's, and other disorders.
Georgia Tech is poised through tremendous development over the last years and our position as leaders in the biosciences, bioengineering, biotechnology to really and truly reach a new level, and this new facility will allow us to do that.
Building on Georgia Tech's strength as a leader in biomedical engineering and the biological sciences, EBB is the first phase in a long-term plan to expand the infrastructure and resources in these vitally important fields. It is located at 10th Street, between State Street and Atlantic Drive, which will reopen as a pedestrian walkway. The facility is adjacent to the Biotechnology Complex, the UA Whitaker Biomedical Engineering Building, the Ford Environmental Science and Technology Building, the Molecular Science and Engineering Building, the Parker H. Petit Biotechnology Building, and the Marcus Nanotechnology Building. The research that will be done within the Engineered Biosystems Building will have a significant impact on the state's economy by driving innovation, commercializing new devices, drugs, and technologies, forming new companies, and creating high-skill, high-paying jobs. Disease is not simple. To understand it and to beat it, we must quantify, analyze, and manipulate the cellular logic of life. The research neighborhoods of the Engineered Biosystems Building have been designed and programmed to facilitate this vision. One research neighborhood is chemical biology, using the power of chemistry to synthesize and manipulate biology.
The kinds of diseases that we are working on are mainly related to the immune system, so things like inflammation, autoimmune disease. We also do vaccination, but we also work in cancer. So actually the immune system plays a big role in cancer, and so we're always kind of looking at the immune and inflammatory side of things. I think it will really kind of promote more cross-pollination of ideas. So I'll be with a mix of chemical engineers, chemists, and biologists, and so I think that my students will learn a lot from them and vice versa, where when we're kind of isolated in our own little room, we only talk to each other.
So the Engineered Biosystems Building is going to be an incredibly exciting place where we have investigators from a variety of fields with students all working together in an environment with good support facilities to create new science. And that mix is incredibly seductive to people like me. We're very excited. My students and postdocs and myself are very excited to get in this building and start mixing it up.
Another research neighborhood is cell and developmental bioengineering, harnessing biological principles to design novel cell-based therapies.
We have collaborations with Hong Lu in using her microfluidic chips to assay the performance of T cells that are expanded and are going to be put back into patients for adaptive cell therapy for cancer treatment. Putting all of us together in a single building with a very fluid lab environment and shared equipment and resources, I think is going to create a very vibrant research environment.
The third research neighborhood is systems biology, which ties it all together by using computation to model life and how it fails in disease.
Cancer research at Georgia Tech, what makes it unique is the integrative approach we're taking, where we combine the expertise of engineers, computer scientists, and molecular biologists like myself. What the new building is going to do is bring people from these diverse fields into one place so that we can work on a daily basis. And so it's really going to be helpful and accelerate, I think, the progress that we're doing in this field.
With this combination of people, collaborations can start from anywhere. We have identified themes, programmed the building around faculty, designed an amazing building, a building that will inspire us to do better than we have. It's these fundamental discoveries that will ultimately lead to new insights about diseases and disorders. It's in that way of making things more efficient and in really understanding the fundamentals that insights for saving lives will come.
This facility will significantly enhance Georgia Tech's commercialization efforts, stimulate job growth in the state, and generate new startup companies. We invite you to be part of this exciting project.